For thousands of years, the Arabian Desert has kept its secrets. Beneath shifting dunes larger than skyscrapers, under sands that can reach 150 degrees Fahrenheit, something has been waiting. Something that would change everything we thought we knew about ancient civilization. In March 2025, artificial intelligence did what decades of traditional archaeology could not. It found them. Not one settlement, not two, but evidence of an entire lost civilization, 5,000 years old, buried beneath one of the harshest environments on Earth, the Rub al-Khali, the empty quarter. A desert so vast it spans 250,000 square miles across Saudi Arabia, Oman, Yemen, and the UAE. So hostile that for centuries it was considered impossible to explore thoroughly until now. This isn't science fiction. This isn't speculation. This is verified archaeology, published in peer-reviewed journals, confirmed by ground expeditions, and what they found challenges everything we believed about early human civilizations in the Arabian Peninsula. Ancient trade routes connecting civilizations we never knew existed, fortified settlements with sophisticated water management systems, evidence of metalworking, agriculture, and organized societies thriving in what is now empty desert. The question is no longer whether advanced civilizations existed in Arabia 5,000 years ago. The question is, how many more are still buried beneath the sand? And what secrets will they reveal about humanity's forgotten past? Welcome to the discovery that's rewriting Middle Eastern history. Welcome to the lost civilization found by artificial intelligence. Let's start with what we thought we knew about ancient Arabia. For most of the 20th century, mainstream archaeology painted a simple picture. The Arabian Peninsula during the Bronze Age was sparsely populated by nomadic tribes. Civilization, we were told, flourished in Mesopotamia, Egypt, and the Indus Valley, but not here. The desert was too harsh, water too scarce, survival too difficult for anything beyond small, mobile groups. But that narrative was based on absence of evidence, not evidence of absence. And there was a good reason for that absence. Nobody could look beneath the sand. The Rub al-Khali, Arabic for empty quarter, is one of the largest continuous sand deserts in the world. Imagine an area bigger than France, covered in sand dunes that can reach 820 feet tall. Summer temperatures exceed 50 degrees Celsius. Sandstorms can last for days, and the dunes shift constantly, erasing any surface evidence of the past within years, sometimes months. Traditional archaeology requires ground surveys. You walk the land, spot pottery shards, notice unusual terrain features. But in the empty quarter, there's nothing to see. Everything is buried. Everything is moving. Everything is hidden. Yet clues existed. In 2002, archaeologists excavating near Dubai stumbled upon Saruq Al-Hadid, a site rich with Bronze Age artifacts, metal tools, ceramics, evidence of sophisticated metalworking dating back 5,000 years. But the site was just a glimpse, a tiny window into something much larger buried beneath the sands. For 2 decades, researchers knew more was there. They knew Saruq al-Hadid wasn't isolated. But how do you find buried cities in 250,000 square miles of shifting desert? The answer came from an unexpected place: artificial intelligence, and from a technology originally designed for military reconnaissance. Enter Dr. Diana Francis and her team at Khalifa University in Abu Dhabi. Their mission: develop a way to see beneath the sand without digging thousands of test pits across the desert. The solution combined 2 technologies. First, synthetic aperture radar, or SAR. This is satellite-based radar that can penetrate sand, vegetation, even buildings. Unlike optical cameras that photograph surfaces, SAR sends microwave pulses into the ground and measures what bounces back. Different materials reflect radar differently. Stone walls return strong signals. Buried structures create distinctive patterns. Ancient pathways leave traces in soil density. SAR can detect these differences even when they're buried meters deep beneath sand. But here's the problem. SAR imagery is complex. A single satellite pass generates gigabytes of data. Analyzing it manually would take years. You need to distinguish natural geological features from human-made structures. You need to filter out noise. You need to recognize patterns that indicate ancient settlements. This is where artificial intelligence enters the story. Dr. Francis and her team, working with researchers from Sorbonne University, Abu Dhabi, developed a machine learning algorithm specifically trained to recognize archaeological features in desert environments. They fed it data from Saruq Al-Hadid, a site already excavated and verified. The AI learned what buried Bronze Age settlements look like in SAR imagery. The patterns it learned were subtle. Linear features indicating ancient pathways, material density clusters suggesting buildings, changes in soil composition marking human activity. Then they unleashed the AI on satellite data covering the Rub al-Khali. What happened next stunned everyone. The algorithm didn't just identify a few promising spots, it mapped an entire network. Trade routes connecting oases, fortified settlements, clusters of structures suggesting organized communities, all hidden beneath the sand, invisible to human eyes, but perfectly clear to the trained AI. As Dr. Francis explained to reporters, with the climate, plus the fact that a lot of the country is desert, it was too logistically challenging to survey the desert on the ground. That's why satellite imagery was crucial. We needed equipment that could look under the sand. The results were published in the journal Geosciences in early 2025, but publishing was just the beginning. The real question remained: were these AI predictions accurate? Was the buried civilization real? Only one way to find out: dig. Ground verification teams arrived at the coordinates provided by the AI. In some locations, they found nothing. False positives are inevitable with any detection system, but in others, they found something extraordinary. Discovery. 1. The Fortified Oasis Network. In northwestern Saudi Arabia, researchers confirmed what the AI had predicted: a network of at least 6 walled oases, some dating back 5,000 years. These weren't simple camps. They were permanent settlements surrounded by defensive walls up to several meters thick. Why build walls around an oasis? Because water was life. Control the water, control the region. These walls weren't built to repel armies. They were built to establish ownership, to mark territory, to protect vital resources in a harsh environment. Inside these fortified oases, excavations revealed evidence of agriculture. They grew cereals, fruits, and dates. They raised livestock. These weren't nomads passing through. These were settled communities with agriculture, property rights, and social organization sophisticated enough to mobilize the labor needed to build massive stone walls. Discovery 2. The trade routes. The AI identified linear features connecting multiple sites. Ground teams confirmed these were ancient pathways, trade routes linking oases across hundreds of miles of desert. This was the revelation that changed everything. These communities weren't isolated, they were part of a network. Goods moved between settlements, ideas spread. Culture developed not in isolation, but through contact and exchange. Dr. Diana Francis noted, "You're not just finding isolated structures, you're seeing corridors of human movement, economies, migration routes, entire civilizations that had adapted to live in the desert long before modern infrastructure." Discovery. 3. Saruq al-Hadid's hidden extent. At the original Saruq al-Hadid site, the AI revealed that what archaeologists had excavated was just a fraction of the actual settlement. Beneath the surrounding dunes lay structures, pathways, and material clusters suggesting the ancient community was far larger than anyone realized. Artifacts recovered from new excavation zones confirmed the site's importance as a metalworking center. Bronze tools, copper implements, slag from smelting operations. This wasn't just a settlement. It was an industrial center, producing metal goods traded across the region. Discovery. 4. Climate clues. Perhaps the most important discovery wasn't about the civilization itself, but about the environment it inhabited. 5,000 years ago, the Arabian Peninsula was not the desert it is today. Paleoclimatic research reveals that during the Bronze Age, the region experienced what scientists call the Arabian humid period. Monsoon rains penetrated further inland grasslands, covered areas that are now barren. Rivers flowed where only sand exists today. The civilization wasn't built in a desert. It was built in a green land that slowly turned to desert as the climate changed. As conditions became harsher, settlements were abandoned. Sand buried the remains, and history forgot they ever existed. Until I found them again. Now we enter more speculative territory. What you're about to hear represents theories that mainstream archaeology hasn't fully accepted, but that the evidence increasingly supports. The Bronze Age collapse connection around 1200 BCE. Civilizations across the Mediterranean and Middle East collapsed. The Mycenaeans fell, the Hittites vanished. Egypt's new kingdom declined. Trade networks that had connected the ancient world for centuries suddenly broke down. Historians have proposed many explanations. Invasions by mysterious sea peoples, drought, earthquakes, systemic failure. But what if part of the answer lies in Arabia? The newly discovered trade routes suggest the Arabian Peninsula wasn't peripheral to Bronze Age civilization. It was central. Copper from Oman, frankincense from Yemen. Goods moving between Mesopotamia, Egypt, and the Indus Valley traveled through Arabia. If climate change gradually made those routes impassable, if the oases dried up, if the network collapsed, would that have contributed to the broader Bronze Age collapse? Some researchers now think so. But this theory remains controversial because it challenges the traditional narrative that places Arabia on the margins of ancient history, the diffusion versus independent development debate. Another controversial implication, the sophistication of these settlements suggests Arabian Bronze Age societies were more advanced than previously believed, which raises a question: did they develop independently or through contact with Mesopotamia and Egypt? Traditional diffusionist theories assumed all innovation radiated from the cradles of civilization, Mesopotamia, Egypt, the Indus Valley. Other regions simply adopted technologies invented elsewhere. But what if that's wrong? What if multiple regions developed sophisticated societies simultaneously through parallel innovation rather than diffusion? The Arabian evidence suggests exactly that. The metalworking techniques at Saruq Al-Hadid show local innovation. The fortification styles are distinct from Mesopotamian architecture. The agricultural systems were adapted specifically to desert oases, not copied from river valley civilizations. This challenges Eurocentric narratives of ancient history. It suggests human ingenuity and civilization emerged in more places, more times, than we've acknowledged. The AI bias question. Finally, there's a question that makes archaeologists uncomfortable. Is the AI finding real sites, or is it seeing patterns that aren't there? Machine learning algorithms can develop biases based on their training data. If the AI was trained on Saruq Al-Hadid, might it be over-identifying features that look like Saruq Al-Hadid but aren't actually archaeological sites? Skeptics point out that not every AI prediction has been confirmed by ground teams. Some identified structures turned out to be natural geological formations, but proponents counter that the verification rate is remarkable, far better than random chance. And as more sites are excavated, the accuracy improves. The AI is learning, refining, getting better at distinguishing ancient settlements from natural features. The debate continues. But one thing is certain: AI has opened a door that traditional archaeology couldn't. Whether that door leads to revolutionary discoveries or expensive false leads, only time will tell. The Arabian discovery isn't isolated. Across the world, AI and remote sensing are revealing lost civilizations in environments previously considered too difficult to survey. In the Amazon rainforest, LIDAR, laser-based remote sensing, has revealed massive pre-Columbian cities hidden beneath jungle canopy. Sites in Brazil and Bolivia show sophisticated urban planning, earthworks, and agricultural systems supporting populations in the millions, all buried and forgotten until technology made them visible again. In Central America, AI analysis of LIDAR data uncovered over 60,000 previously unknown Maya structures in Guatemala. What we thought was empty jungle was actually a densely populated civilization landscape. Population estimates for classic Maya civilization have doubled based on these discoveries. In Egypt, satellite-based ground-penetrating radar has identified potential buried structures near the Giza pyramids and in the Valley of the Kings. While not yet excavated, these anomalies suggest major discoveries remain beneath already heavily explored areas. In Mongolia, AI applied to satellite imagery has mapped ancient Silk Road trading posts and Mongol Empire infrastructure across vast steppes where ground surveys would take decades. The pattern is clear. We've barely scratched the surface, literally, of human history. Entire civilizations remain hidden, waiting for technology to reveal them. But this raises profound questions. How many lost civilizations are there? How often has human society risen, flourished, and been forgotten? And what does that mean for our understanding of progress, collapse, and resilience? The Arabian discovery represents a paradigm shift. Archaeology is no longer limited by what we can see on the surface or dig by hand. We're entering an era of digital archaeology, where algorithms explore landscapes humans cannot. What's next? The Khalifa University team is expanding their AI system to scan other regions. North Africa's Sahara Desert, the Thar Desert in India, the Taklamakan Desert in China. Anywhere that hostile environments have hidden ancient settlements, AI can now search. New satellite systems are launching with higher resolution radar, machine learning algorithms are improving. Computing power is increasing. Each year, the technology gets better, faster, more accurate. Some researchers propose using AI not just to find sites, but to predict where undiscovered civilizations are most likely to exist based on patterns in climate, geography, and known settlements. Imagine an algorithm that doesn't just analyze satellite data, but reasons about where to look in the first place. The human element. But technology alone isn't enough. Every AI prediction must be verified by human archaeologists. Every discovery requires excavation, analysis, interpretation. The digital tools augment human expertise. They don't replace it. As Dr. Diana Francis emphasizes, the algorithm identifies possibilities humans decide what they mean. This partnership between artificial intelligence and human wisdom may be the future not just of archaeology, but of historical understanding itself. Beneath the empty quarter, beneath sands that have buried history for 5 millennia, a lost civilization has been found. Not by accident, not by luck, but by human ingenuity channeled through artificial intelligence. The fortified oases, the trade networks, the metalworking centers. All proof that when we claim a place was empty or uncivilized, what we really mean is, we haven't looked hard enough. Arabia was never empty. It was full of life, culture, innovation. Climate change turned grasslands to desert. Time buried the evidence. But the story was always there, waiting beneath the sand. This discovery reminds us that history is not a closed book. Every generation rewrites it with new evidence, new tools, new perspectives. What we believe today about the past will be revised tomorrow. And that's not a failure of knowledge. That's the triumph of curiosity. How many more lost civilizations are out there? How many forgotten peoples left no written records, but built cities that endured for centuries? How much of human history has been erased by time, climate, and geography, but remains hidden, waiting for us to develop the tools to find it? The answers are coming. One satellite pass at a time, one AI prediction at a time, one shovel stroke at a time. The empty quarter wasn't empty after all. And neither is our understanding of the past. We're just beginning to fill in the blanks. What do you think? How many more lost civilizations are waiting beneath the world's deserts, jungles, and oceans? Let us know in the comments where you're watching from and where you think the next great discovery will be. If you enjoyed this deep dive into archaeology and AI, subscribe to Lost Worlds Decoded. We bring you the discoveries that rewrite history. Every single week, the past isn't dead. It's not even past. It's just buried. And we're learning to dig with algorithms,